this video, I will demonstrate how to use the debugger in Visual Studio Code to trace your program execution. I'm connected to the CS server already, so let me open an existing project. Open folder. The project is in CPP project folder, and then P2 is the project. So open it. The program is quite simple. So I have a main program. The main part is I have a loop 2 through 10, and then calling function f1. Function f1 is compute the sum of integers 1 through the parameter s, and then the result is returned, and then that is printed in a loop. So to trace this program using debugger, first we need to configure a debugger file, configuration file. So this icon on the left hand side is a debugger mode, run or debugger mode with a bug icon there. Click on that, and then we need to create a launch.json file, which is for debugger. So click on that, and then choose a C++, GDB, LLDB, and then choose a default configuration. So what we need is a configuration named GDB launch. This is the one. So if you don't get this one at this through these steps, then click on add the configuration on the bottom right corner, add the configuration, and then choose C++ launch. This is the one. As you click that, now you will get GDB launch there. So I have 2 copies of those one, so I can delete the one just added. Is not needed. So that's the configuration for debugger, and then we need to edit the program part. The program will be a.out on the current working directory, so we can just delete those comments part out and then leave from $. So at the from the current project folder, a.out will be the executable file for that. So let me close this one, go back to the main, and then to debug it, to run it, we need to compile the program. So view, terminal, then G++, -G option should be provided to compile with the debugger symbol. If you don't give a -G option, you cannot run the debugger. Enter. And then a.out is created as executable file, but now it includes a debugger symbol. To run the debugger, you need to have at least one breakpoint. As you move your mouse prompt, the left-hand side of the line number, small red circle appears. So click on executable code. Assignment is executable code. So breakpoint is set. You can put as many breakpoints as you like. But let me explain that later. So the purpose of a breakpoint is as the debugger runs, a program execution pauses or stops at the specified line. So program execution will stop at line 8. Line 8 is not executed yet. So to start the debugger, click the green triangle button, click, then debugger runs, and then program pauses at line 8. Line 8 is not executed yet. On this variables window, local variables n and k are defined, but the values are meaningless at this moment since they are not initialized yet. Then debugger mode, execution control is here, control panel is here. So this one with a arc arrow is a stopover. Stopover is a program execution goes to the next physical lines. As I click step over, program pauses at 9, line 9, line 8 is executed. So n gets a value 20. So here, as I do step over, line 9 is executed. The cout message is on terminal window down here. So shows up, step over. Now line 14 is to be executed. So if I do step over, line 14, k gets a value, n plus 1 is there. And then here I enter the loop. Step over is always go to the physical line by line. So step over, if I do step over, function 1 is called with the value I, and the return value is k. K is 3. So 1 through 2 addition is 3. Step over, and then line 16 is about to be executed. There, I is less than 10 or not, equal to 10 or not is checked. Currently I is 2, it's true, so we continue the loop. Now k is 6, 1, 2, 3. 3 are added. So we do the loop like this, continues. So I is now 6, continue. I is 8. I is now 9. I is now 10. So this is the final step. K is 55. 1 through 10 integer summation is 55. Then now I is 11. So we end the loop. We are about to exit the main function. If we want to restart the debugger, you can stop button here, stop, and the debugger is debugger mode is exit, so you can start the debugger mode again by clicking the triangle. Now let me show you another one. Step over goes to the next physical line for execution statement, and then here line 17 I have a function call. Another one is next to the step over is a step into. Step into is when the line includes a function call, you step into, jump into the function definition. So step into, now we are in function 1. At this moment the local variable is s, which is parameter. S is 2 as we expected. The 2 is a passed. Now result is uninitialized yet. Now initialized to 0, and then we loop, and then as you do step over again, well, function ends, and then it resumes where it was left off, and it continues the loop. Now we are in 17 again. If you can do step over, or at line 17 you can do step into again to jump into the function, and then you don't need to check the details of a function 1, so you want to get out of this function immediately, then there is a step out button. Step out, you leave the function and it resumes where it was left off, and then it continues the execution. So we can stop the debugger. Now I can add, I can do this way. So run the debugger again. Pause the line here, but I want to investigate something in the loop. Then you can add another breakpoint, and then you can go to the next breakpoint. Here is a continue button. Continue button is go to the next breakpoint immediately. So all done. So you are in the break loop, and then you can now do step over or step into, step over, step out, and so on. You can do that. Also, you can add a breakpoint while you are in the debug mode. So here, if I can add a breakpoint here, then even if I do step over here, at this moment the function call is when executed. Here breakpoint is inside the function call, so program pauses at the breakpoint. You can also remove a breakpoint by clicking the red dot again, and then just do step out and step over. Then you don't get paused inside the function 1 again. As you find some bug or issues you want to modify the program, then you have to pause, stop the debugger, and then you can edit the program. Then be sure to compile the program again with a -G option, G++, -G main.cpp. Then you can now restart the debugger to check the updated or revised code.